you think back to graphing a system of equations, what we do is we graph each of the equations, and then the solution is where those equations or where those graphs intersect. So if we're graphing a system of inequalities, we're going to do pretty much exactly the same thing. It's just that when you graph an inequality, you have some shaded region, and so the solution then is going to be the region of space that is shaded by both inequalities. So let's get an example of that. The top equation here I will graph in red. Now this one is in slope-intercept form, so we can find the y-intercept of -5, slope of -2, so that's going to go down 2 and to the right 1, or you could think of that as up 2 and to the left 1, and then we'll graph that line. Now it should be a dotted line since we have y is strictly greater than, so we're going to draw a dotted line here. Then if we look at where to shade, it says y is greater than the equation, greater than the right side of the, inequality, not equation. So if it's greater than, we're going to shade above. So I will shade in all of this whole region up here. And then we just have to graph the other inequality and find where they intersect. So this one I will graph in green. This one has a y-intercept of 3. And then it has a slope of 1. This one's going to be a solid line though, since it's less than or equal to. So solid line. And then it says y is less than x plus 3. So we want all the y values underneath. So we're going to shade everything underneath this line. And then the solution is the part that is shaded by both. So that's going to be this region in here. So what's shaded with both green and red, that part that I just shaded in blue, that is the solution. All right, if we have an equation that is not, an inequality that is not in slope-intercept form, my favorite way to do this is to get it into slope-intercept form. You can, of course, graph by finding x and y intercepts. So that would be plug in 0 for x, to find the y-intercept, plug in 0 for y to find the x-intercept. But then you've got to be a bit more careful about how you do the shading. So then you might want to use the point test to do shading. So that would mean plug in any random point into the inequality and see if you get a true statement or not. If you get a true statement when you plug in a point, you want to shade the side of the line with that in it. If you get a false statement, that's not part of the solution, so you'd shade the other side. For me, I prefer to just solve this for y. So on the top, I would subtract x from both sides, and that would leave you with y is less than or equal to -x plus 8. So that has a y-intercept of 8 and a slope of -1. This line is going to be solid because it is less than or equal to. And then we want y values less than that -x plus 8, so we're going to shade in underneath. For the second inequality, I'll do this one in blue. So for this one, we want to get that y by itself. We could start by subtracting 4x from both sides. That'll leave you -y on the left side. So we want to make that positive y. We could just multiply everything by -1. Remember that with an inequality, when you multiply or divide by a negative number, and I just did that wrong, you want to flip the inequality around. So then we get that. All right, let's graph that. That's going to have a y-intercept of -6, a slope of 4, so we go up 4 to the right 1. This one's going to be a dotted line. And then we want y values less than that, so we're going to shade underneath. Now the solution is the portion of the graph that is shaded by both inequalities. So that's going to be this part right down here. So the solution here is shaded in red. We can do this with an absolute value equation as well. So let's first graph the top one, which is just y is less than or equal to 3. So remember that the line y equals 3 is going to be a horizontal line with all the y values being equal to 3. So that's going to look like this. So So every y value on that line, every point on that line has a y value of 3. Solid line because it's one of the or equal to's. And then we want y values less than that, so that's going to be shading underneath. Second one is the absolute value. So this one has a horizontal shift of 4. It's going to shift to the left 4. That's what this, oops, that's what this right here does. So let's shift the vertex to the left 4. And then the number up front, you could think of that as being a 1. So it has a slope of 1 for the right side. And then we mirror that for the left side. Oh, I forgot to do it a dotted line though. All right, and then we want to graph above that. So y values greater than that is going to be above. So we'll shade in everything above. And the solution again is where both of these are shaded, which is going to be just this, this small part right in the center. It's going to be this right here. So underneath the horizontal line, but above the V. So that's the red area right there. All right, on the top, this one is not in slope-intercept form. This one I am actually going to graph using intercepts, so meaning I will plug in 0 for x to find the y-intercept. I'll plug in 0 for y to find the x-intercept. And when we're doing this, we're going to pretend for a moment that this is an equal sign so that we can get the actual value that we're going to graph. So if we plug in 0 for x, that first term will disappear. That just goes away. We get 3y equals 6. Divide both sides by 3, and we get y equals 2. So that's the coordinate point 0, 2. We plugged in 0 for x, and we got 2 for y. Then we do the same thing to get the x-intercept, except we plug in 0 for y. That one I'll do in blue. So if we plug in 0 for y, we get 2x plus 3 times 0 is equal to 6. That thing goes away. We get 2x equals 6. Divide by 2 and we get 3. So for that one, we get an x value of 3. And we got that when we plugged in 0 for y. So that's going to be this point right here. Then we can draw our line. So like I said, we need to be a bit more careful about how we figure out the shading. Let me draw the line first. This is going to be a dotted line. So I like to use the 0, 0 for the point. So what we're going to do then is plug in 0, 0 and see whether or not we get a true statement. All right, so 2 times 0 goes away, 3 times 0 goes away. That's what makes it nice to plug in 0, 0 because you get all those zeros that just disappear. And we get 0 is less than 6. That is a true statement. So that means we're going to shade the side of the line that has the point 0, 0 because that's part of the solution if we get a true statement. All right, so we're going to shade, let me make that bigger, we're going to shade underneath over here. All right, the second equation then, I'll graph that one in red. This one's slope-intercept form, so that's fairly simple. But we get, let's see, up here plus 4, and then a slope of negative 2/3. So down 2 and to the right 3. And this one's going to be a solid line. So you see these lines are actually parallel to each other. So then when we shade this in, the second equation, it says y is greater than or equal to. So that means we're going to shade above, which means that there's no intersection here. So just like if you have parallel lines, in normal solving systems of equations by graphing, when you have parallel lines, there is no intersection, and so you get no solution. Well, with this one, we've got parallel lines. The bottom line is shaded below. The top line is shaded above. There is no intersection here, so this one has no solution. All right, let's graph this one. You may notice right off the bat that these are also parallel lines. So you might think there's no solution here, but let's graph it and see what happens. All right, so the first one has a y-intercept of 3, slope of 2, so we're going to get something like this. And then what we do is we shade Let's see, below, because we have y is less than, so we want things underneath the graph. The second inequality has a y-intercept of -1. And the slope of 2, so we go up 2 to the right 1. This one's a solid line. And my pen's not working. There we go. Okay, I got a little bit off the point there, but that's okay. And then we shade, let's see, shade above. It says y is greater than or equal to for the second one. So we're going to shade above. So you'll notice in this one there is actually an intersection. Even though the lines are parallel, there is an intersection of the shaded parts. So I will shade that part in blue so that you can see it. So that's going to be this area right here between the lines. That's where both of the lines get shaded. And so that blue strip right there, that is the set of solutions. And the last thing we're going to do is a system of 3 equations. Sorry, 3 inequalities. So again, we just graph all 3 of these, find where they all intersect. So the top one, I'm going to do that one in green. Y-intercept of 8, slope of -3. So it's going to look something like this, and it'll be a solid line because it's less than or equal to. The less than part of it tells us to shade below. Second inequality, sorry, I keep saying equation, these are inequalities. All right, that one has a y-intercept of 5, slope of 1/2, so we go up 1 to the right 2. And this one's going to be a dotted line. This one also gets shaded below because it says y is less than. All right, so now we do have a portion of the graph that is overlapping between the blue and the green. So that's kind of the bottom left portion of it. But again, we have 3 inequalities here, so we've still got to satisfy the third one. This one says y is greater than or equal to 0. So we have the horizontal line y equals 0. That's going to be solid because it says y is greater than or equal to. And then what we're going to do is shade above. So we get all of this area above. And then for the solution to the system of 3 inequalities, we look for the area that is shaded in by all 3. So that's going to be this triangle right in here, shaded in black. So right in the center of that triangle, shaded in with black, that is the solution to the system of 3 inequalities.